Hello, greetings from Ireland and welcome to the first public engagement workshop for MUSICA. My name is Dara Sheehan and I'm an electrical design engineer working with NeoDyne. We are proud to consider ourselves partners of such an innovative and promising project here in the beautiful country of Greece. NeoDyne have a large role to play as chief electrical integrators in the design and development of the MUSICA platform. I hope to outline this role in this short presentation, and in doing so, maybe shed some light on some of the technical aspects of MUSICA. But first, a little about who we are. NeoDyne is an Irish company founded in 1998 in County Cork in the south of Ireland. We're a company of 120 engineers who have a broad range of skill and experience in electrical integration and automation projects. We have worked on many renewable energy projects carving the way to a more sustainable and greener planet. We pride ourselves on finding the most effective and efficient solutions to modern day problems. Our role as electrical engineers in MUSICA is to combine all of the systems to operate as one. I will hand you over to my colleague Peter Froggatt to explain this in greater detail.
Hi, my name is Peter Froggatt and I am a design and automation engineer in NeoDyne. First of all, what exactly is an MUP? The MUP, or multi-use platform, is an offshore floating platform which combines several renewable technologies to produce clean and desalinated water together with an autonomous aquaculture unit. To combine these and make them work in unison is our task here at NeoDyne. The MUP will also improve renewable penetration of the existing island grid. Wind force, that is kinetic energy contained in moving air currents, spins the blades. These blades are designed to capture its energy. They are made of very light and resilient materials, and this is why they can produce energy at very low wind speeds. The blades are coupled to a shaft, which in turn is connected to a generator. The generator converts kinetic energy into electricity, a source of energy which is easier to transport and use. The electricity in the generator is conducted through the tower to the base. There is a transformer which converts the electricity into a usable voltage. The alternating current, or AC voltage, of the wind turbine is connected to a 400 volt bus. The sun emits energy in the form of rays. These range in length from short ultraviolet to long infrared rays. When the sun is shining, the rays hit the surface of the solar cells. Some of the rays pass through the cell, some are reflected back, but more rays are absorbed into the solar cell, creating an electrical imbalance, which in turn causes current to flow. A solar cell typically only produces a few watts, but combining hundreds of such cells can produce a considerable power output. The goal of MUSICA is to have upwards of 60,000 watts of solar energy generation. This would be the equivalent of powering 30 homes. The Aquaculture Unit is an autonomous fish farm which will have a scheduled feeding process controlled by a Main Controller, or PLC. A blower will supply fish feed from a small silo on the MUP down a pipe and into a large fish cage. Remote monitoring systems will measure key parameters of the fish farm, ensuring the fish are healthy and the farm is operating correctly.
Desalination Plant. The desalination plant on board the MUP will provide fresh potable water using renewable energy. The system pressurizes salt water from the sea through a filter to remove the salt. Batteries. During times of low renewable power generation, such as during the nighttime or low wind conditions, it is necessary to supply the platform with power to maintain the essential systems and to ensure the fish feeding system can operate. This is where lithium-ion batteries come in. We are designing for a large bank of highly efficient lithium-ion batteries to back up the electricity supply to the platform during these low res generation periods. HPES. The HPES, or Hydropneumatic Energy Storage System in MUSICA, is an innovative technology being designed by the University of Malta to store energy in large high-pressure vessels on the MUP. During periods of high energy generation, We will run pumps to pressurize large vessels of air and seawater to 70 bar and store this energy in the form of compressed gas. When the energy is required, we then release the gas through a nozzle and direct it towards a Pelton wheel turbine, which in turn is connected to a generator supplying 400 volts to the MUP electrical grid. All of these components need to be combined and controlled using a system custom designed by the NeoDyne engineering team. This system is called the EMS. It will now be explained in the following slide. The EMS system, or energy management system, is the set of components displayed here that work in unison to electrically control all the MUP constituent systems. Central, Main Plc. The PLC is the main computer or control system on the platform. It is the brains of the EMS system and processes all the information necessary to control the EMS. Telecoms. The telecommunication system enables information to be sent and received wirelessly so that the MUP can be monitored and controlled remotely. Scada Pc. The Scada system provides an interface for users to control and monitor all systems on the MUP. Key information can be gathered and stored on this system for research and troubleshooting purposes. Transformer. The main transformer converts the 400 volt and 690 volt power sources of the MUP to 20 kilovolts, which is the high voltage used for transmission of power to the island of Anusis. Inverter. The inverter will convert DC or direct current generated on the MUP to AC or alternating current, which can then be used in the distribution system. MV switchgear. The medium voltage switchgear is the main circuit breaker for the MUP. The circuit breaker acts to protect the electrical equipment by tripping open and breaking the flow of electricity during a fault situation. LV switchgear. The low voltage switchgear consists of smaller circuit breakers used to protect the hardware on board the platform. Much like the MV switchgear, these circuit breakers act to cut off the supply of electricity during electrical fault scenarios. Cable to shore. The cable to shore will be designed to export power from the MUP, supplying the island of Anusis with clean, renewable energy generation. Metering. High-spec metering will be used throughout the EMS system to monitor the power quality of all the systems which generate power on the platform. That concludes our short presentation on what will be a wonderful project. From all of us at NeoDyne, thank you.